Welcome back to the C++ series. Continue from where we ended last time. We're talking about classes and dogs. We talked about lots of dog breeds. We didn't talk about many. We just talked about one, a Labrador Retriever. We should also have a Golden Retriever as one. You can keep a German Shepherd, but never should you keep a Rottweiler or a Doberman Pinscher, unless of course you want to kill the neighbor's child next door. But this is not about dogs, anyways. It's about C++ coding, programming, encapsulation, getters and setters, access modifiers, and later on we do inheritance. So we continue from where we ended last time. We did mention that you have access modifiers, and by default they're going to be private for the class if you don't specify. Right. Although you still want them to be public, or some of them, not all of them. What does that even mean, anyways? Or if you're public, it means you can access them from outside the class, but you don't want that because you don't want to change important class variables. In most cases, you don't. So you make them private so that it can only be accessed by class methods, and the user can only have access to them through getters and setters. Now that's what's called encapsulation. They're hiding the interface from the implementation. So instead of doing this for our dog here, I was going to copy and paste, but then I realized that it was going to be a bad way to do it. So I think I should probably kill the terminal here. Just move it down a bit. Cool. I'm going to delete everything in this class. And we're going to start again. I'm going to delete everything in main, apart from return 0. Okay, I'm going to delete everything in main, apart from return 0. So we're going to start, and this is how we start. So make everything private first. Private. So what's going to be private? The name of the dog. Maybe the breed also. The age. And the mass. So these are private. They can't be accessed unless from within class fields. The next thing we're going to make is public getters and setters. And in most cases, the first public thing you make is a constructor. So for now, let's just have a default constructor. So if you don't provide any arguments, it's called a default constructor. Now, do that and then say default constructor. Okay. So to make any object, the compiler calls a certain function called a constructor. And a constructor is a special kind of function. Remember, all other functions, if you watch the video on functions, all the functions have a return data type and the name. So they have a return data type and of course a name of a function. This constructor does not have a return data type. Why? Because it returns the object. Okay. It has the same name as the class name. Okay, for now I think you should know that. We're not going to use it much. And maybe I'm even going to skip it. I don't know. Yeah, but then it's a default constructor. And then you can make getters and setters. So ways of accessing your class variables. Okay. So they're going to be start with setters. So setters accept an argument. And change the class variable. Okay, cool. So we start with our setters, and I'm going to make void. So they're mostly going to be void because they don't return anything, and it's recommended to keep your setters to be not so long, anyways, to only have one argument. So I'm going to void set name. Okay, now you don't have to call it set them by itself. Okay, so set and you're setting the name. So we're going to get a string argument. Then it's going to get a name. But then you should avoid this. You should avoid, or you shouldn't avoid. It's recommended actually to name it the same name as this. But then you just have to have a way of describing which one is this name in this function and which one is the name in this class. Okay, so I'll avoid that for now. It's about pointers. So for now, you can say n for the name, string breed, the breed. Oh no. That's just setting the name. Okay. So all it does is that it gets this name and set is equal to the argument. So just say name is equal to n. Then you make another setter. You call it void set breed. Set the breed. Okay. So you say string b, and you say breed name is equal to b. So this breed name in here is going to be equal to the breed name, the b in the argument. And you say void set age. You say int a. It's not recommended to name them like this. It's recommended to name them the same name as this, and then use this keyword. So here, the best method would have been to say this name is equal to name. If you're using Java, it will look something like this. But name is equal to name. Okay. So for now, we haven't yet dealt with pointers, so I'm going to talk about that. That's edge. You're going to say edge is equal to a, and then you have void set mass. I'm going to say is int and then just say mass is equal to m, the same in the argument. Those are setters, so these are modifiers, right? They're modifying. And then let's get access. So getters. Okay. These give you access. Alright, so we're going to get in string. So this one's return the variable. So string, let's call it get name. Yeah, no argument. What it just does is return name. It returns this name. Okay, that's how it does. So you can assign that name somewhere else, and then you can say string get breed. No argument. All it does is return the breed. You can see sometimes some more things in your getters and setters, but it's recommended to keep them short. And string get age. No argument. All it does is return the age. String get mass. That's the last one. No arguments, and all it does is return the mass. Cool. So there you have it. We now have our getters and setters. So we're going to make a variable. I'm going to call it dog, my dog. Okay. And then maybe let's ask the user cout. Oh no, goodness. Cout. We're going to make a few variables in here. They're going to be string name, string breed, int age, and double mass. Okay, so I'm going to say cout. Enter the name of the dog, and cout into the breed. Goodness. And cout into the age. Probably here you want to enter. So I'm going to say cin the name, cin the breed, the one we just made, and cin the age. And out, I'm going to say enter the mass of the dog. Probably going to say cin mass. Cool. There goes. And then I can coin my gates and status. So I've made an object of dog and it's called my dog. So I'm just going to say my dog. Sorry, this object I made. Dot set name. I'm going to call my setter. And I'm going to provide an argument. The name we just entered. I'm saying my dog dot set breed. I'm just going to provide the breed you've entered. So it's going to modify them. My dog dot set age. I'm going to provide the age you've entered. And my dog dot set mass. And I'm going to provide the mass you just entered. Okay. And then to get the items, I'm going to say cout. Maybe let's say the name. Let me not make it boring. Okay, let me make it one line. My name. I probably want that. It's going to be my dog. Dot get name. No. Get name. Maybe the breed is going to be my dog dot get breed. Cout the age is going to be my dog dot get age, and the mass is going to be my dog dot get mass. Cool. I'm going to run that code. It's valid C++ code. It's going to work. We've made our own variable, our own data type. We've called it dog. Let me just check. Oh, I added three S's there. I don't know what's wrong with me and threes. Compile and run that. Oh, it's a small b. Compile and run it again. I still have an error there. I call it breed name. So here should be breed name. Age. What did I call the age? Oh, supposed to be an integer and it's supposed to be a double. Alright, not a string, because age is a string. There goes, that should work. Okay, that's a compilation, and then let's try compile and run. Oh goodness. I'll save that. I'm supposed to compile and run, and that's supposed to execute. I don't know what's wrong with dev. I'll probably copy it. Maybe I should move it to a new file. And I'll paste it here. I just save the new file as dogs.cpp. I'll save that and I'll execute that. Okay, let me just see where I should run. Yep, should run. Okay, it looks like they won't work, so I'm going to run it in Visual Studio Code. Still valid C++ code. I'm just going to make a new file here. I'll call it dogs.cpp. I'll kill the terminal for now, and I'll paste it in here. There goes. Alright, there goes. And quite a lot of lines of code. I'm just going to go to my new terminal, and I'm going to compile that dogs g++dogs.cpp. Okay, kill that terminal, save that. It's about the compiler. Okay, sure. That's why I like Visual Studio Code. It gives me, I should delete because I'm not even using it anyway. Alright, it gives explanations on what's wrong with your code when you're debugging. So you're not always going to get correct code, of course, but then about the constructor as sorry. Okay, that compiles as we thought. Enter the name of the dog. It's going to be called Scott. It's going to be a pit bull. I don't know if that's how you spell pit bull. And my pit bull is 2 years old. The mass of the dog, pit bulls are pretty heavy. I'm guessing 15 kilos. I think they're even heavier than that. Okay, so it's printed out the name, Scott, the breed, pit bull at the age 15. Okay. And if that's running Visual Studio Code, I can now go back to dev and run it in dev. So I can use any of these two files I made. I'll just delete the constructor. Where's the constructor? Let's see. Okay. Yeah, and that works also in dev. So enter the name of the dog. We're going to enter, I think we're still going to Scott. The breed is going to be a golden retriever. So let's just say retriever. The age is my retriever is 4 years old. Mass of the dog, it's about 13 kilos. Then there you have it printed out, called retriever, the mass is 13. So there you have it. That's how you deal with getters and setters, and this is called encapsulation. It's recommended to use the constructor. Remember, uh, as you can see here, I have too many things on setting. Let's say I have lots of class characteristics. So it's recommended to use the constructor, and when once constructor just initialize everything. We'll do that in a later session and explain how the constructor is, no need to worry. But for now, that's how you do this.